Hi, Year 11, this is our third lesson for the topic of functions. In this lesson, we're going to cover composite functions. So far we've covered functions and relations, function notation, piecewise functions, and domain and range. Now, a composite function is a function inside another function, and this is what we write. This is f of g of x. Now in this case, the output of g of x becomes the input of f of x. So it looks like this. We have some x value, goes into g, it comes out as g of x, and then it goes into f, and that's what is outputted, f of g of x. Let's have a look what this looks like. For f of x is equal to 2 minus x, and g of x is equal to the square root of x, find f of g of x. So we're going to take g of x and put it inside f of x, like this. Now wherever we find an x, we're going to put the square root of x, so the answer is 2 minus root x. How about this one, g of f of x? So we're going to take f of x and stick it inside g of x. So this is going to become g of 2 minus x. So wherever we see x, we're going to replace it with 2 minus x in here, which of course is the square root of 2 minus x. Now I've just thrown this one in because this is not a composite function, it's a combined function. And here we're just multiplying f of x by g of x. So it becomes 2 minus x in brackets multiplied by root x, or root x times 2 minus x. Example 2. If f of x is equal to x cubed and g of x is equal to x minus 1, find f of g of 3. So we're going to start by working out g of 3. It's equal to 2. And now we're going to take that 2 and put it inside f of x. And f of 2 is equal to 8. G of f of negative 3. So let's start by working out f of negative 3. It's negative 27. Take the negative 27 and stick it inside g of x. So g of negative 27 is negative 28. And example 3, sketch the following and state the domain and range. F of x is equal to 1 minus x squared. Well, that's an upside down parabola, isn't it? And it's moved up 1. So it looks like this. The domain is all real numbers, and the range, y has to be less than or equal to 1. Now let's sketch g of x is equal to the square root of x. Now this is a sideways parabola. So if we take y is equal to the square root of x, and square both sides, we've got y squared is equal to x. So this looks like this. But of course we've only got the positive square root, so it is a function, so we don't have this bottom part here. So it looks like this. Now the domain is x is greater than or equal to 0, and the range is y is greater than or equal to 0. Now let's sketch g of f of x. So remember, we're going to take f of x and put it inside g of x, so we get the square root of 1 minus x squared. Now that's a semicircle. It's centered at 0, 0 and has radius 1, and it's the positive semicircle. So it looks like this. Now the domain is everything from negative 1 to positive 1, including both of those points, and the range goes from 0 up to 1. And finally, let's draw f of g of x. So we're going to take the square root of x and substitute it into f of x. Now this question looks really easy, but it's a little bit more complicated. This is just a straight line, isn't it? It's got a negative gradient and a y-intercept of 1. But let's have a look at our diagram here. So the x's that are going into g are greater than or equal to 0. And the output of g here is also greater than or equal to 0, which means the input into f are numbers greater than or equal to 0, because remember, the output of g becomes the input of f. So what effect does that have on this? x is always going to be greater than or equal to 0. The biggest this can be is 1. So the range of this function is going to be y is less than or equal to 1. Our domain is x is greater than or equal to 0. Our range is y is less than or equal to 1. And so we do have a straight line, but it's chopped off here. Now this begs a couple of questions. Is f of g of x the same as g of f of x? We've seen that a couple of times in this video that no, they're not the same. Are they ever the same? I'm going to leave that question with you, and I'm going to also leave this question. Can we predict the domain and range of a composite function from the domain and range of individual functions? So there's a couple of questions for you to think about. That's it for this lesson. Our next lesson is on inverse functions.